Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, this is Lesson 8, using if-then moves in solving equations. Alright, so first thing we're going to look at is what is an if-then move. So we're going to recall them and then we're going to summarize them. So let me bring those in. Okay, so here's the first one. If a number is added or subtracted to both sides of a true equation, then the resulting equation is also true. Okay, so it says if A equals B, then A plus C equals B plus C. And if A equals B, then A minus C equals B plus C. Okay, and the next one is if a number is multiplied or divided to each side of a true equation, then the resulting equation is also true. If A equals B, then A times C equals B times C. And if A equals B, and C is not 0, then A divided by C equals B divided by C. And C cannot equal 0 because anything divided by 0 is undefined. It is not 0, it's not 1, it's not that number. Is undefined. We cannot divide by 0. Okay, so then they give us an opening exercise which says write 3 plus 5 equals 8. As many true equations as you can using the if-then moves. Identify which if-then moves you used. So try that and come back and see if you've done it correctly. Okay, so here we go. So it says write 3 plus 5 equals 8 as many true equations as you can. So if I say if, and there's infinitely many choices here, if 3 plus 5 equals 8, comma, and you can pick any number, 3 plus 5 plus 7 equals 8 plus 7. Alright, so it says if A equals B, so this, let me color code these. This piece here, 3 plus 5 would be my A. And 8 would be my B. So A equals B. 3 plus 5 equals 8. That is true. So I have an A that equals a B. Alright? Then A plus C equals B plus C. So that's all we're saying right here. That's what we're doing. We're adding a C. C is 7. So if A is 3 plus 5 and it equals B, which is 8, then A, 3 plus 5 plus some C equals that B, which was 8, plus that same C, 7. And that is definitely true. Okay? The next one, I can also say if 3 plus 5, that's my A, equals 8, which is my B, A equals B, then 3 plus 5 minus 2 equals 8 minus 2. And 3 plus 5 is 8, minus 2 is 6, 8 minus 2 is 6. So they're true because what you do to one side of an equation, you do to the other. So that's really what we're talking about here. What you do to one side, you have to do to the other. Okay, next one. If 3 plus 5 equals 8, we have to have a true hypothesis, that's what that's called. Then we have to have a true conclusion. If P, then Q. Alright, I don't know if we've gotten there yet, but that'll come up in possibly geometry. So here we go. 3 plus 5, and we've done addition, we've done subtraction. And now I'm going to multiply it by a number. Let's multiply it by 3. Equals 3 times 8. So now we're saying if A equals B, A equals B, then A times some C3 equals B times that same C3. And that is also true because 3 plus 5 is 8, 8 times 3 is 24, 8 times 3 is 24, 24 equals 24. And then finally the last one, if 3 plus 5 equals 8, then the quantity 3 plus 5 divided by some number equals 8 divided by some number. Okay, so we're going to get 8 divided by 6, which is 4/3, and 8 divided by 6, which is 4/3. Okay, so in this one here, we added 4 to both sides. 4. What did I add? 7. Okay, add 7 to both sides. Okay, in this one, we subtracted 2 from both sides. Okay, and in this one, we multiplied both sides by 3. And in this one, we divided both sides by 6. Okay, here's example 1. Julia, Keller, and Israel are volunteer firefighters. On Saturday, the volunteer fire department held its annual coin drop fundraiser at a streetlight. After 1 hour, Keller had collected $42.50, more than Julia, and Israel had collected $15 less than Keller. The 3 firefighters collected $125.95 in total. How much did each person collect? Find the solution using a tape diagram. Okay, so who are we comparing everything to? Keller had collected 42 more than Julia, and Israel had collected 15 less than Keller. Okay, so the first thing I want to do is do a tape diagram. And each one had a similar amount, and then we're going to be a more than or less than in each one. So there is the tape for Julia. That's what Julia collected. That's what Keller collected. That's what Israel collected. But it says here, Keller collected 42 more than Julia. So here's Julia's. So 42 more than would probably be something like this. 42.50. So we don't know what Julia collected, but Keller collected 42.50 more than her. And then it says Israel collected 15 less than Keller. Okay? So I need a tape diagram that is shorter than this, and the missing piece is 15. So this piece here would be 15. So 42.50 minus 15 is 27.50. Okay? So now Julia collected a certain amount, Keller collected 42.50 more, and Israel collected 27.50 more than Julia because it was 15 less than Keller. All right. The total was 125. All right. Okay, so when I don't know a value, I'm going to use a variable, and I'm going to call these values x. So if I set up an equation to solve this, it's going to be Julia's x plus Keller's x plus 42.50 plus Israel's x plus his 27.50 because it was 15 less than 42.50, so that's 27.50. And I'm going to combine my like terms. So I have an x, I have an x, I have an x, and the other like terms is the constant 42.50, 27.50. So x plus x plus x is 3x plus 42.50 plus 27.50. Well, 50 cents and 50 cents is a full dollar, so don't forget to carry that 1. 7 plus 2 is 9 plus 1 is 10. Carry another 1. 2 plus 1 is 3 plus 4 is 7. Okay, so it's 3x plus 70 equals 125. All right, so we're talking about if A plus B I'm sorry, if A equals B, this whole thing, then I can say A minus C equals B minus C. So in other words, we are going to subtract 70 from both sides. What you do to one side, you do to the other. So I end up with a 3x here. 70 minus 70 equals 0. So I'm going to show that. Plus 0 equals 5 minus 0, 9 minus 0, 5 minus 0, 12 minus 7. Okay, so now I have 3x equals this. So if I have A equal to a B, and I divide both of them by C, and C will be my 3 in this case because I want to get rid of this 3, and I get x equals 3 goes into 5 once, 3 goes into 25 8 times, the remainder of 1, 3 goes into 19 6 times, remainder 1, and 3 goes into 15 5 times. Okay, now go back and answer the question. How much did each person collect? Okay, so this is Julia. Julia collected $18.65 because Julia was just X. Keller collected $18.65 plus this $42.50, which equals 5 plus 0. 6 plus 5 is 11, carry the 1. 8, 9, 10, 11, carry the 1. 1, 5, 6. Okay, so Keller collected $61.50. And then finally, Israel collected $18.65, the X, plus $27.50. 0 plus 5 is 5. 5 plus 6 is 11, carry the 1. 3 plus 8 is 11, carry the 1. Did I do that right? 0 plus 5 is 5. 5 plus 6 is 11, carry the 1. 7 plus 1 is 8, and 8 is 16, carry the 1. And I get 4. Okay? So Julia collected $18.65, Keller collected $61.15, and Israel collected $46.50. So we answered the question. Okay, so now it says, what were the operations we used to get our answer? And the answer is, first we added $42.50 and $27.50 to get 70. Next, we subtracted 70. Well, I didn't do that, so. All right, let me go back. What were the operations we used to answer? So what I would say was, first, oh, that's right. First, I added 70, or subtracted 70 from both sides. I subtracted 70. Okay. So first, we subtracted 70 from both sides. And then we divided by 3 both sides. Okay? So we first subtracted by 70, then we divided by 3. I'm not going to take the time to write that. Okay, the amount of money Julia collected is J dollars. Write an expression to represent the amount of money Keller collected in dollars. Okay, so Keller collected, if we go back, Julia's amount plus $42.50. Okay, so that's what I'd write. J plus $42.50. Okay, using the expression for Julia and Keller, write an expression to represent the amount of money Israel collected in dollars. So if I go back, look here, Israel collected Julia plus Keller minus 15. Okay, so that would be Julia plus Keller, which was the $42.50, minus 15. Okay? Or we could just combine the like terms and say Julia plus 2750. Alright. Using the expressions written above, write an equation in terms of J that can be used to find the amount each person collected. Alright, so we're going to have Julia plus 4250 plus Julia plus 2750 equals 125. Okay, so this was our total. This was Keller. That was Israel. This was Keller. So what Julia collected plus what Keller collected plus what Israel collected equaled that. Then it says solve the equation written above to determine the amount of money each person collected and describe any if-then move used. Okay, so here's what we would do. We would rewrite that. J plus the quantity J plus 4250 for Keller's amount plus J plus 2750. I've got an extra J in there. I got thinking about that. This should not be there. Okay, so it should just be Julia plus Keller plus Israel. Okay. Alright, so Julia plus Keller plus Israel equals the total. Combine like terms, J plus J plus J, there's 3 J's, plus 4250 plus 2750 is 70, equals 125.95. And I could do 0, 0 there. Okay. So then I would subtract 70 from both sides. Okay, these cancel, and I get 3J equals 55.95. And then divide by 3. So therefore, J equals 8.65. Okay? So on this step here, any order, any grouping, okay? This one here, subtract 70 from both sides. Oh, I combine like terms. This was subtract 70 from both sides. This was divide both sides by 3. Okay. Example 2. You're designing a rectangular pet pen for your new baby puppy. You have 30 feet of fence barrier. Okay, so the first thing I would do is draw and label a diagram, which is what it says, but that's what I've always done. I didn't even have to read that right there. That's the first thing I always do when I am given a word problem with a shape. Draw a picture. You have a 30 feet of fence barrier. You decide that you would like the length to be 6 1/3 feet longer than the width. So the width plus 6 1/3 feet. Okay? You have 30 feet of fence barrier. So that's perimeter. We want the perimeter to equal 30 feet. Remember, perimeter is this side, plus this side, plus this side, plus this side. So we let the width of the pen be W, and the length of the pen be W plus. So this is length. The width plus 6 1/3 feet. Okay. So if the width is W, then the length is W plus 6 1/3 feet. Okay? Find the dimensions of the pen. Okay. So I'm going to do this algebraically. So we know that perimeter is length times width, or length plus width plus length plus width. So I'm going to write that. Perimeter equals 2 lengths plus 2 widths. So I have a length here, I have a length here. I have a width here, I have a width here. So that's 2 of each. Okay? Or I could do it this way, rather than confuse you with distributive property. And I could say P equals length plus width plus length plus width. Length plus width plus length plus width. So that, and then I substitute in my given. Perimeter is 30 equals the length W plus 6 1/3 plus the width W plus the length, which is W. I'll put those in parentheses. Plus 6 1/3. Okay, so these are our lengths plus the other width over here. So 30 equals all this. Combine like terms. W plus W plus W plus W is 4W plus 6 1/3 plus 6 1/3 is 12 2/3. Okay. So in order to simplify this, I'm trying to find out what W is. So I have a plus 2 2/3, so I have to subtract it from both sides. So I'm going to subtract 12 2/3, subtract 12 2/3. And I'm going to be left with 4W, because these cancel, equals. Well, I'm going to have to borrow from here. So I'm going to call this 29 3/3. 3/3 minus 2/3 is 1/3. 9 minus 2 is 7. 2 minus, so I'm down to 17 1/3. Go over here now. I'll rewrite that. 17 1/3 equals 4W. I need to divide both sides by 4. And then I will get W by itself. Divide both sides by 4. So this will cancel and leave W over here. And I'm going to make this a mixed fraction. 17 times 3. 7 times 3 is 21. 51 plus 1 is 52 4/3. So 52 thirds divided by 4. Remember the rule, flip it and switch it. Multiplicative inverse. 52 thirds times a quarter equals W. 52 times 1 is 52. 5 times 4 is 20. Okay, and then we simplify. 20 goes into 52 2 times. That's 40. Remainder 12. 12 20ths is 6/10 or 3/5. So the width is 2 3/5 feet. Okay, I just noticed an error. It's not 52/5, it's 52/3. So this is not 20, it's 12. So let's get rid of that. Move up here. 52 divided by 12. 12 goes into 52 4 times. That's 48. The remainder of 4. 4/12 is 1/3. My apologies for that error. I went from 3 to a 5 for some reason. Okay, so the answer is 4 1/3, the width. Did I answer the question? Write the expressions to represent the width and length of the pen. Okay, so here's width, 4 1/3. The length is the width plus the width. The length is width plus 6. So the length is 4 1/3 plus 6 1/3. So therefore the length is 10 2/3. Okay? I should say 4 1/3 feet, 10 2/3. Okay? Find the dimensions of the pet pen. So I've done that. That is right here. Okay, example 3. Long exercise. Example 3. Nancy's morning routine involves getting dressed, eating breakfast, making her bed, driving to work. Nancy spends 1/3 of the total time in the morning getting dressed, 10 minutes eating breakfast, 5 minutes making her bed, and the remaining time driving to work. She spends 35 1/2 minutes getting dressed, eating breakfast, and making her bed. How long was her drive to work? Write and solve this problem using an equation. Identify if-then moves used when solving the equation. Okay, so in this we don't know the total time it takes her to get ready. 1/3 of the total time is getting dressed. So I'm going to write that as 1/3 x. X is the total time of her morning routine of getting ready. Okay, plus 10 minutes to eat breakfast, plus 5 minutes to make her bed, and then the remaining to drive to work. Nancy spends 35 1/2 minutes getting dressed, eating breakfast, and making her bed. How long was her drive to work? Okay, so this total is getting dressed, which is 1/3 of her total time, 10 minutes to eat breakfast, and 5 minutes to make the bed. She spent that total time of 35 1/2 minutes getting ready. So there's our equation. So we want to find out how long it took her to get dressed. 1/3 total time. So the first thing I want to do is combine these two like terms. So it's going to be 1/3 x plus 15 equals 35 1/2. Okay. So in order to get rid of that, the first step is we're going to do, remember it's PEMDAS, is what we use, that's the order we use to simplify expressions. But when we're solving equations, we go backwards. So we're trying to get this x right here by itself, so we do SAD math. So we do subtraction and addition first. So I want to get rid of this 15. I want to get it away from x. I want x to be all by itself on the left. So if I subtract 15, and I subtract 15 from this side, okay, I'm left with 1/3 x. 15 minus 15 is 0. And then I get 35 minus 15, which is 20, and then that 1/2. Okay, so now working up, I just did the subtraction and addition portion. Now I'm at division and multiplication, and I have 1/3 times x, so I'm going to multiply by the reciprocal, 3/1, and multiply this side by 3/1. So these are going to cancel, and I get x equals, okay, this is 20 1/2 times 3, which comes out to be 3 times 1/2 is 1 1/2, and 3 times 20 is 60. So 60 1 1/2 is 61 1/2. Okay? So that is her total routine of getting ready. She spends 35 1/2 minutes to get dressed, eating breakfast, making her bed. How long was her drive to work? So 61 1/2 was the total. So if I take that 61 1/2, that's getting ready and driving to work, and subtract the amount of time to get ready. Okay, 1/2 minus 1/2 is 0. 61 minus 35 is what we're really doing, and if you want me to, I'll write this. 1/2 minus 1/2 is nothing. 6 to 5, 11 minus 5 is 6. 5 minus 3 is 2, so the answer is 26 minutes to drive to work. Okay? Is your answer reasonable? Explain. So you have to think about this. 1/3 of the total time is getting dressed. A third of 61 is approximately 20 minutes to get dressed. 30 minutes and 5 is 35. And that's pretty close to 35.5. So yes, it's reasonable. So you should always check to see if your numbers align and make sense. Okay? Example 4. Actually, before I say example 4, let me be more specific about this. Is your answer reasonable? Explain. Okay, so I will put this in here for you. I'll give you the opportunity to read it on your own, and I'm going to move on. So if you need to read this, pause the video. Okay, here's the next example. The total number of participants went on the 7th grade field trip to the Natural Science Museum consisted of all of the 7th grade students and 7 adult chaperones. All 7th grade students plus 7 chaperones. Two-thirds of the total participants rode a large bus and the rest rode a small bus. 54 students rode the large bus. How many students went on the field trip? Okay. Alright, so how can we set this up? Let S equal the number of students. Okay? So it says 2/3 of the total participants. And the total participants were students plus 7 adults. Okay? All of the 7th grade students plus 7 adult chaperones equals, if 54 students rode the large bus, how many students went on the field trip is the next question. Okay. Okay, so 2/3 of the students and the adults, everybody, rode the large bus and the rest rode the small bus. Okay. 2/3 of the participants rode the large bus. So 54 students rode the large bus. How many students went on the field trip? Okay, so 2/3 of the total participants rode the large bus, and there were 54 on the large bus. The reason I'm pausing here and thinking about this is they're not saying that any adults were on the small bus, but let's just go with this for now. And we're going to solve this problem by doing the multiplicative inverse. So I want to get rid of this 2/3, so I'm going to multiply both sides by 3/2. Okay? 3 cancel, the 2's cancel, we get S plus 7 equals 54. Think of that as 54 over 1, and it is even. So I can divide it by 2. So half of 54 is 27. 3 times 7 is 21, carry the 2. 3 times 2 is 6, plus 2 is 8. So 54 times 3/2 is 81. Then finally we want to get S by itself, so we should subtract 7. And we get S equals 70. Okay? So 74 students went on the field trip. Okay? That's the end of lesson 8. Do your problems.